Graph theory came to be when Leonhard Euler encountered an old problem about the town of Königsberg. The problem is called the Seven Bridges of Königsberg, or simply Bridges of Königsberg. It was about the river Pregel in dividing Königsberg into 4 separate parts, and these parts are connected by 7 bridges. The problem was figuring out if it was possible to cross all of the bridges exactly once. Euler found that it was impossible to find that route, but it was possible for other cities. This led to him finding a rule that can be used for any city, and this was what led to the graph theory. He converted the city maps into graphs by turning every region of land as a vertex, which are these dots here, and every bridge is an edge, which are these lines connecting the vertices. The rule was that no more than 2 islands or vertices have an odd degree, so there may exist a route that crosses each bridge exactly once. Now that I've explained the basics of graph theory and how it came to be, I am now going to discuss how it's used in something we use every day, Google. We've all probably used Google to search up a definition of something, to learn about an unfamiliar topic, and then you'll most likely click on the first result. But did you know that there's an algorithm behind how those websites end up in our search results? Enter PageRank algorithm, named after Larry Page, co-developer of the algorithm and co-founder of Google, together with Sergey Brin. PageRank, or PR for short, is an algorithm used in Google search to determine and rank the importance of sites. Google then places the most important website at the top of the search results. It determines the website's importance by the number and quality of links connecting to the page. It assumes that the more website that links to a certain site, the more important that site is. The algorithm includes the damping factor D that computes the probability distribution that a person randomly clicking on links will keep on clicking. But I'm not going to delve into that. I'll just show how the algorithm determines the website's importance without considering the damping factor, and how graphs can be used to illustrate this. First, I should probably explain some terminologies. The websites are the vertices, and the hyperlink that connects to these sites are the edges. And this entire network of websites and hyperlinks are called a web graph. The hyperlink that links to a website is called the inbound link, while the hyperlink that links out to other websites is called the outbound link. These links are what makes this a directed graph. As the name implies, it means that the edges have a direction. The higher the PR of a page, the higher the value it gives to the site it's linking to, but the number of outbound links the connected page has will lower the value it gives to your website. This is shown in the formula below, where the PR of A is the PageRank of website A, PR of T sub I is the PageRank of pages T sub I which link to website A, and C of T sub I is the number of outbound links on a given T sub I page. This is done so that even if someone tries to cheat and create multiple pages that links to a certain website, it will still not be on the top of the search results because those pages have low PRs, so it doesn't contribute much to the value of the website. To demonstrate this, here's a web graph of 4 sites, and you want to know site A's PR. First, we have to assume that every website has a PR of 1 divided by the number of pages, which is 4. So in iteration 0, all sites have a PR of 1/4. Iteration is the number of times the formula is looped. Now we have to get the value the other sites give by using the formula. So the PR of A is 1/4 divided by 1, which is 1/4. 1/4 is the PR of B in iteration 0. The PR of B is 1/4 divided by 1 plus 1/4 divided by 2 plus 1/4 divided by 1, which is 5/8, where this is the PR of A, this is the PR of C, and this is the PR of D. The PR of C is 0 because it does not have any inbound links. The PR of D is 1/4 divided by 2. We repeat that with the next iterations, stopping at iteration 4 where site A and site B will just keep on switching PRs, so we will stop there. The number of iterations either already determined beforehand or when it reaches convergence, meaning the values don't have very significant changes anymore. Here we can see that site A has the highest PR, so it will be the first entry that shows up in the search results, followed by B, then C and D. Notice that even if A only has one inbound link, it still has a high PR. This is because the inbound link from B has a high PR and only one outbound link. Now that we know each website's importance, we can now illustrate the website sizes based on their importance. Here we have the new web graph illustrating the importance of each website based on their respective page ranks. Okay, now that we've discussed how graphs are used in computer science, let's now move on to how it is used in social networking. Don't worry, there are no computations this time, so we can give our brains a break. Anyways, while PageRank can be visualized as a directed graph, social network is visualized as an undirected graph. This is because if A is friends with B, then B is also friends with A. An undirected graph is a graph where all of the edges don't have a specific direction. Let's now move on to an example. Say you want to know how many people your Facebook post reaches if you set the people who see it to friends of friends. You are A and are friends with B, C, and D. For simplicity's sake, let's say all of your friends has 4 other friends. You, your friends' friends are the vertices, and you are all connected with an edge. Now we can see that the post will reach 20 people. Now imagine you are friends with more people, and those people has an equally many friends as you do. That one post could easily reach hundreds, if not thousands. Now after doing some research on this network of friends, you find out that the majority of the people are 20-year-olds. Now what if that post was an advertisement for your online business? You can use that knowledge so that the ad can fit the demographic by adjusting the words so that it appeals to the target market. Your friends and their friends will see it and are more likely to be interested in your products. You'll be selling hotcakes in no time. Today we learn about how the graph theory came to be, how PageRank is computed, and how graphs can illustrate those connections and importance of websites. And then illustrate social networks where you can then apply the knowledge you get from it to promote your business.